Welcome. This video is for developers who know a bit about custom shader coding and Unity or similar engines that is not familiar with Unreal Engine but want to learn how to implement or convert their shaders into Unreal Engine. So the complexity of the shader in question is up to you. What I will show you, however, is a simple starting point for fundamentals, all right? So what is shown on screen right now is a summary of an example shader that I will convert, and I will have workflow tips along the way. And versions I'm using in this video is Unity 6 and Unreal 5.5.1, along with some glsl that is using glsl 460. And learning outcomes from this video: you will have an idea of where to begin when converting custom shaders from Unity or any tool of your choice for that matter into Unreal. So I will briefly touch upon differences between glsl and hlsl and Unity and Unreal Engine in order to convert simple shaders. And this video will be split into parts. Introducing Unity and a simple minimal version shader to convert, followed by introducing Unreal Engine materials and how to interface the shader code with the engine. So I'm going to assume that you either have experience with the editor or look up the very basics for Unreal Engine in other videos, alright? I will then show how to convert the simple minimal shader to Unreal along with workflow tips for this. And after that, I will go through a basic list of differences between glsl, hlsl, and Unity and Unreal versus any other glsl engine that you might use. We will then go through another set of shaders using texturing, LOD texturing, and then finally an animated effect using all of these concepts. Okay, so here we are in Unity, and these rocks right here, this material is what I'd like to convert and create in Unreal instead, right? But we're going to do this in steps, and first off as well, this material is not lit by like a surface shader. Any of the lighting calculations, complicated lighting calculations, is not happening. The reason why this looks shaded is because it's got a Fresnel effect in the shader, a really simple effect, just to show some simple inputs into shaders and how to convert those as well into Unreal. Okay, so we've got a step along the way is this material. And what this shader looks like, I'm going to convert this one first into Unreal. And what this one looks like is like the following. It's got a simple shader that has a vertex and a fragment program, right? And it's got vertex data and fragment data, and the vertex program and the fragment program. And vertex data is position, clip space, normal, UVs. That is then input into the fragment shader, the position clip, and the UV, and we also generate in the vertex program the position, the world position, and normal in world space, and the view direction in world space as well. And that's as follows with the usual suspects from Unity: the functions Unity object to clip position, and the Unity object to world to get the position in world space, and we use also the world space position to get the Unity world space view direction, and also the normal is piped through Unity object to world normal. So we have everything in world space. When we get down to the fragment program, that does the following: just set up a frag color to save the color of the fragment. Use the UV as a local variable just for convenience, and then we set the alpha. It's not used, this alpha, right now, but set it regardless to 1.0. And then we've got a gradient that has a little bit of simple cosine arithmetic going on here with the time is a variable from Unity, globally available. That's not going to happen in Unreal. We're going to have to replace that, right? And the UV with some swizzling and some offset for RGB, and that, oops, that creates a gradient effect. Set that to frag color, and then just a simple Fresnel as well that uses normal and the view direction, and lerping between just to have some softening of the Fresnel effect, really. So that's a simple first one that we're gonna convert. Looks like this in Unity, and over in Unreal it looks like this. But first off, now in Unreal I have this as a final product. The rocks look like this in the end. So first off though, and this is by the way like a bunch of default settings, mostly just a little bit of water and sky added, because why not. So first off though, in case you're very new to Unreal, we've got the content browser down here, very similar to Unity's asset folder in the project tab, right? So here, similar to Unity, I can create a material by right-clicking or add material, and because of naming conventions I use m_, and let's just do a test for now just to show you. And by the way, the little star down there begs us to save. It doesn't save that one because it's saving, if I'm clicking this one, it's saving the level actually, but we can use file, where is it, save all, Control Shift S, and this is I'm going to use this very often. So now the star is gone. In case of a engine crash, you would want to Control Shift S quite often. So regardless, if I head into this one by double clicking, right? So in here we're presented, this is a material. This is a graph, a material graph, where we can express, similar to how a shader would calculate a base color, a metallic, or a specular value, or emissive color, we can express arithmetic in here through nodes. So let me just show you a very simple one, is to pipe an emissive color in here, and I can do that by creating a constant 3 vector, like so. And of course we've got like a color picker here. We can set the values individually, but I'm gonna set it to like let's set it to purple. And it doesn't show right now because I need to do this, right? And now it's loading a little bit. Now, okay, that's purple. By the way, I can just control this mesh over here, similar to any viewport. So here's a constant vector 3, or a float 3 in hlsl, piped into this emissive color. What happens now if I head over here and let's say I want to add just a simple cube, right? Place it up here. Now it is orange because it's lit by the sun over there actually, but because this mesh right now is using this material, the basic shape material. So what if I just set it to my M test? It doesn't show. It shows a placeholder material because it hasn't actually compiled correctly just yet. So we need to remember this one, apply. Quite important. So now if I apply this, it's going to load, it's going to put a star on this one, which is a separate action, is to save it as well. And the level is also not saved right now, but it will show the actual color that I put in here, right? So I'm going to save all there as well. Remember to save all. Okay, So in here, I could do a bunch of arithmetic and stuff, right? Like add or multiply. I'm not gonna show this a whole lot, but like sine, you've got the all of the good stuff in here as nodes, right? But this is so doing this in nodes is a little bit slower to get from this bunch of code, right, into nodes. And it could be a little bit buggy if you're not very familiar in using the node system to recreate the shader, essentially. But what we could do is have an intermediate step where we have actual code inside of here as well. So I'm gonna show that alternative instead. First off though, here's another thing. In the output node of any material, we've got a bunch of options. So we want a surface material domain, not a post process or anything. There's a bunch of options there. We could set this to translucent, but we're going to use opaque, and we could set it to unlit, which disables a bunch of these like surface lighting calculation stuff, right? So only emissive. Okay, so given that we know how to create materials, we can try to recreate this material from Unity, right? This simple one, this code from here, and it's mainly the fragment shader part that is going to be of interest here, because we can replace all of these inputs from the vertex shader. So I'm going to reuse this test material, and let's remove that and create a custom node and pipe it to emissive. And I will grab, well, let's recreate this. So we want a frag color variable. UV is going to be i.uv, but we're going to remove the i dot, so uv equals uv doesn't make any sense. We can just use this as an input later, define this as an input. So also frag color.a redundant because we've got the one here. So I'm gonna just grab the gradient part here and insert here. The indentation is a little bit off unless I include everything. Here's one thing. Underscore time, the Unity global variable, is not going to be found. Well, we could define the input as underscore capital T time, but I'd rather use lowercase for all of the inputs. Okay, and UV is also going to be an input. Everything else is constants and assigning to frag color. And there we go. Next one is the Fresnel as well. And over here, it will not recognize i.normal world or i.view direction world. So I'm going to remove i dot. We could have i dot, but I'd rather get this simple right now. So this is going to be an input, and view dir world is going to be an input. So now it remains, one thing remains, return frag color. There we go. Now here's where it's going to complain about not knowing what time is, for example, and time.y and view dir world and normal world and stuff. So what I suggest is going one at a time here, and over here in the settings for this custom node, we've got the code and output type, of course, float 3, and we've got inputs. Now, defining these ones one at a time. So time is one input. Oops, there we go. And now it's going to give an error before it shows anything else, because I need to provide this input with something. So I'm going to just give it time. Let me do this a little bit slower. I'm searching for time, and there we go. That just gets a float from the time, the current time of running. So time.y is also not very useful because the Unity struct time has x, y, z, and w, but our time only has one float, okay? So that's the better way to do it. And also we need another input because this UV, defining this, is done as following. UV, and then we input that with texture coordinate, and that's done. And then it needs view dir world, and we select this one, add another input, expand, name it view dir world, enter. View dir world, we could do similar to how I did it before, where it's world position, and then I did some arithmetic here with which is subtract the camera position. It's also another one, camera position, WS for world space. But we could also, by the way, click this little neat arrow down here, which gives us another option, absolute world position or camera relative world position, including or excluding material shader offsets. I'm not going to touch that right now, but this could be our view direction in world space. And what remains is another one, normal world. There we go. And normal world is just world space, pixel normal world space. Okay, there we go. Now it shows right off the bat because I've clicked this real time. If you haven't selected this, it's going to give you a still image when you move it, and then when you let it go, it's going to be still. So if you want this to show real time, select that. I can also select unlit, by the way. We can select different preview meshes, and we can also even select the let's see, the rocks, and sets the preview mesh based on the current content browser selection. There we go, to the rocks. And also, this could live update if you select either all node previews or real-time nodes. And by default, this preview window will show what's output in the final node over here, the output node over here. If I hit start preview in node, I can hotkey this, by the way. It's gonna show this one in particular, or this one in particular, for example, the UVs in this case, or the relative precision to the camera, like so. Very useful. When you have a bunch of nodes, it's really useful to be able to do that. But it's also very useful to be able to see all of these in between live updates if you activate these as well. The official documentation, it says using the custom node prevents constant folding and may use significantly more instructions than an equivalent version done with built-in nodes only. So yeah, and here's the link to the documentation where it says. However, it's a good starting point that can be further iterated upon to split into nodes if you wish in the graph to make it more optimized. So in case you have glsl shaders that you want to convert, here's a small basic list of the differences between basic types. And yeah, we've got vec2s, vec3s, IFX, and mat3s, and those are equivalents are in hlsl flow 3, flow 2, into flow 3 by 3. Functions are mostly the same. We lack saturate in glsl, of course, and atan is a tan2 in hlsl and swap the parameters. Very important, x and y. Otherwise, it's mostly the same. And in usage, we've got some minor differences. Like in glsl, you can initialize a vector 3 with only one parameter, implicitly setting all of them to 0.0, right? But in hlsl, you need to specify all three. And multiplications between vectors and matrices are a bit different as well. You need to use the mul function for this. So also touching upon the differences between shader inputs in the different systems, glsl, Unity, and Unreal, is we've got, for example, a uniform time is defined manually in glsl, while in Unity we've got the time global variable that we can use, and in Unreal we've got the time node that is also predefined. For custom uniforms, we would define it similarly in glsl to time, but in Unity we need a property and a uniform float defined, and in Unreal we would need to use a material parameter node, which I'm not going to explain right now. You can check other videos, there's a bunch of them for getting material parameters in there. And texturing would need to call texture function or texture LOD in glsl. In Unity, text2d, text2d LOD, with a minor difference in the UV parameter for text2d LOD. And in Unreal, you would do texture2d sample or texture2d sample level. Another information nugget about this is that Unreal Engine changed in 5.5 to use this syntax that I've listed so far, texture2d sample, while in previous versions below 5.5, I believe it was in 5.4, it would be texture object dot sample, and then you provide the sampler and the object UV parameters. So next up is texturing and how that's done in this context. So here's what it looks like in Unity, and the code for this is as follows. It's got a property uTexture, a 2D texture that's got a uniform sampler accompanying it, and so that we can here in the fragment program sample via the function text2d with the first parameter being the uniform sampler, and then the UV coordinates, the vector 2 as a second parameter, and just simply put that as the frag color, the emissive color, right? And in Unreal it would look like this one, and the material looks like this. It's got emissive color, and the difference here is the function to sample the sampler and also the inputs, right? So texture2d sample is the function which takes a texture object and a sampler and the UV as a 2D vector. Now if I define texture as an input like this, I also get, when I input a texture object into this input, it will also automatically create the same name and suffix sampler with a capital S for me to use as a sampler in such a call, like to be able to sample this texture. So we've got a texture object here. Instead of the regular way of doing this would be to, okay, I want a texture, probably texture sample, right? Makes sense. You could sample a texture like this, but you would get the RGB A values right off the bat here, and we don't want to just input a 4D vector or a vector 4 or a float 3 in here right off the bat, because what if you want to have like a for loop inside of here and sample to make blur, for example, or something like that? So inside of the code we can sample for more flexibility instead by using a texture object, and you find that by just going through the different options for texture here, and we've got a texture object. We've also got a parameter, by the way, but we can make this into a parameter as well. More on parameters later. So as I input a texture object that I choose my texture in here into an input, it will give me whatever I name this input, which is texture right now, also a suffix sampler to use like this. So I figured I would mention texture loading as well, because it's quite useful for effects like blurring and other effects. So in Unity, here's what it looks like, and I did animate this over time just to show more clearly the how it works, and it's just going through the MIP levels. It doesn't make sense for an effect, but just to show you like clearly what's going on. So what this does in Unity is as follows. It's got the same thing. It's got a texture, it's got a sampler, and instead of accessing the texture through text 2D with a texture and a UV 2D vector, we have text 2D LOD and the texture as a first parameter, and then instead of the 2D vector for UV, we've got a float 4 with the UV in the first position, XY, and the MIP level as an integer as a fourth W parameter in this inside of this UV float 4. So here's what I mean with the MIP levels just being cycled through. I use time and floor that, so that when a second passes it will shift to another integer, and we fmod that by 8 to get 0 to 8, and then it circles back to 0 again, just to show circles back to just to show some differences in the MIP leveling. Because I just wanted to show some differences in MIP leveling, just to visualize it, right? So in Unreal, it looks like, if I show this one instead, it looks like this, and the material, it's got the same setup and same code essentially, except for the texture 2D sample level, this part. And instead of the Unity way where it's got a float 4, we've got a UV of a 2D vector and a MIP as a separate parameter. Now, putting it all together, the animated final material looks like this in Unity, and the code is same deal with textures and same parameters, same input to the fragment shader. The only difference is that we use a texture sample, a grayscale texture sample, only the red channel, and multiply it to get a material offset to use here in the gradient, and still have the Fresnel effect as well. So I use the MIP level 5 hard-coded right here, and here's what it looks like in Unreal. And if we head into the material editor, it's the same thing as previously, just combining them all into this effect, right? And that's the final effect. So to end this video, I'll just mention some thoughts and possible expansions upon this for the future. And I recommend having a look at the documentation that widely covers the different material expressions available at this webpage. And apart from that, I was considering putting into this video some form of exploration of the different coordinate systems of the different engines and ways to explain how to interact with those. But I will save that for another video. And for clarity though, here are the glsl shader versions of the shaders used in this video as well.